Okay, so we're going to look at the indicated derivative, dv dt, if v is equal to t minus 1 over t. And so we're looking at this, and we're looking at the limit again as h approaches 0. We're looking at a function v, so instead of f, I'm going to write v here. Usually we put x plus h, but our function is in terms of t, so I'm going to put t plus h minus v of t all over h. So if we go in and we plug in t plus h, wherever we see a t in our function. So doing that, I see a t here. Let me bring down the limit. So I see a t first, so I'm going to rewrite it with t plus h. And then I have a minus 1 over. I see a t there, so I'm going to replace it with t plus h. So that's just this piece. And then we're going to subtract off v of t. And so again, we have to be careful when we're subtracting off a whole function. We need parentheses around that whole function. And so if I subtract off this whole function v, I'd be subtracting off t minus 1 over t. And then we're going to put that all over this h. So let's distribute this negative sign inside that parentheses, and let's bring down our limit. So you have the limit h goes to 0 of t plus h minus 1 over t plus h. This is now going to give me minus t, and then it's going to give me a plus 1 over t. And this is all over h. So notice we can clean this up a little bit in the numerator. I have a positive t and a negative t, and those cancel each other out. So looking at this, the limit as h goes to 0, we have h minus 1 over t plus h plus 1 over t, and this is all over h. So notice if we went in here and we did our direct substitution and we plugged in 0 wherever we saw the variable h, so we would have 0 here minus, oops, that's not an h, minus 1 over t plus h, so minus 1 over t plus 1 over t. Those all cancel, and that gives us a 0 in the denominator and numerator. But also we're going to get a 0 in the denominator. And so recall, if we get 0 over 0, that's an indeterminate form, and it didn't tell us anything. We needed to go back and manipulate this. And so manipulating this, if we had a complex fraction, that is where we multiplied by a fancy one, what I call a fancy one. We look at all the fractions within that main fraction, and we multiply by the LCD. And so our LCD in this case is t, all times the quantity t plus h. So we have to distribute this t, all times that quantity t plus h, to each piece in the numerator. Well, when we distribute it to this h, there's nothing on the denominator, nothing's going to cancel. So let's just rewrite it as that product. So limit h goes to 0. I would have this h here, all times that t, all times that quantity t plus h. Nothing canceled. Now when I distribute that t times that quantity t plus h, though, to the 1 over t plus h, notice those t plus h's cancel, and we're left with a minus. Only thing that would be left is that t, so minus t. Then we have plus. Now we're distributing that t times t plus h to the grouping of 1 over t, and those t's cancel. And we're going to have back just that parentheses t plus h. And I'm going to put this all over my h all times, nothing canceled in the denominator, t all times t plus h. Okay, so let's look at this. Let's simplify this. And so let's see if we have any like terms. So I notice that we have a negative t and a positive t, and those are going to cancel. Right now, I guess we could do it this way. You can either think of it as distributing the h over t in here, or notice that they both have an h in common, so we can kind of manipulate it this way if we want. So this is h, right? Times the quantity t times the quantity t plus h. And then we have this plus sign here. Just put plus there with that. Then we have this h. So technically, all over ht all times t, the quantity t plus h. So technically, we could either factor out this h here, or we can distribute this ht to each term and then factor out the h. Either way, we're going to get the same result. So if we pull out the h in the numerator, well, I would be left with then this t times the quantity t plus h plus, well, if I pulled out the h here, I'm only left with a 1. And then all over this h, this t, all times t plus h. I need to bring down my limit. So now we've made it where these h's cancel. And so if we go in here and we plug in 0 wherever we see an h, we should come up with something other than 0 over 0, but let's just show it. Let me just rewrite this. This is t, all times the quantity t plus h, plus 1, all over t, all times t plus h. We're going to go in here wherever we see an h, we're going to replace it with 0. And so if we did that, we have t times t, or t squared, plus 1, all over, notice the numerator or denominator, this h goes to 0, so we're just left with t times t, which is t squared. And so this is the derivative of v of t. So we can say dv dt, which is equal to t squared plus 1 all over t squared. So wherever the derivative exists, we could find the derivative at those values of our function v of t. Let me pause, see if there's questions, and then I'll come back and answer them if there are.